So consider the situation shown below. So this is the board that is kept over the floor. Friction coefficient between board and floor is given, and this is mu. So mu is the friction coefficient between board and floor. Mass of this person is also given, that is capital M, that is mass of man. Mass of board is also given, that is a small m. And this man is pulling this rope. We have to find maximum amount of force by which this man can pull this rope so that this board cannot slide over this floor. So what is the condition we have? That is, board is not sliding over the floor. So we can say acceleration of board is equals to 0. Now let us say maximum force is T. So T is the maximum force. So this rope will have throughout same force. The tension inside this rope is same. Here we will have tension T. Here we will have tension T. So this tension gets transferred finally to the board. Now we can make free body diagram to solve this problem. So this is the board and this is the man. So man is pulling this rope in the downward direction. So now from the Newton's third law we can say the rope is pulling this man in the upward direction by the same force. So rope is applying a force T on the man, and this is coming from Newton's third law. Other force that is acting, mg, that is mass of board into gravity. We will also have mg in the downward direction. For man, normal reaction on the board is also acting, and there is a friction force, and this friction is mu times n, where mu is the friction of coefficient, and this time this is a static friction of coefficient. So if nothing is given, we will assume this mu is a static friction of coefficient. Tension is also acting over this board. So you see, there is a tension that is also acting. Now we can write equation of motion in vertical direction and horizontal direction. So let us first write in vertical direction. So since there is no motion in vertical direction, total force has to be 0. So upward direction force is positive. So T, normal reaction, is also in the upward direction, and mg in the downward direction. So this is 0. So from here we can say T is equals to, or T plus N is equals to M plus M into Z. So let us say this is equation 1. We can also write equation in horizontal direction. Since there is no acceleration in horizontal direction, this means sum of the forces in the horizontal direction is again 0. So in horizontal direction we have only two forces. One is tension, another is friction force. So tension is equals to friction force. And friction force is mu times N. Now from equation 1 we can plug the value of normal reaction in equation 2. So we can say T is equals to mu times normal reaction, and normal reaction is nothing but M plus M into Z minus tension. So this is coming from equation 1. Now we can solve for tension. So T is equals to mu times M plus M into Z minus T mu. So we can take tension common. So 1 plus mu times M plus M into Z. So from here we can write tension is equals to mu times M plus M into Z divided by 1 plus mu. So this is the maximum force that is applied so that we does not have any slipping between board and floor. If I apply a force that is greater than this force, in that case board will slip over the floor. And if I apply a force that is lesser than this force, board will remain in the rest over the floor. So in this case, board will not slip over the floor. So this is the critical force. At this force, just slipping will start. One can also solve the same problem by considering this man as one system and this board as another system. For example, let us try by another method. So we are considering this board as one system and this man as another system. So on man we have force tension and another force mg, and this board will apply a normal reaction on this man. So there is a normal reaction. So let us call this is N dash. Now from Newton's third law, if board is applying a normal reaction N dash on man, man will also apply a normal reaction on the board. So this is N dash. So N dash is normal reaction between man and board. Now on board we will have another force mg, tension, and we will have friction, that is mu times n, and floor will apply a normal reaction, let us say n. So n is the normal reaction between floor and board. Now we can write equation for man and board separately. So let us first write equation for man. So in vertical direction, man is not accelerating. So we can say total force on man in vertical direction is 0. So we have T plus N dash minus mg, and this is equals to 0. So we can say T plus N dash is equals to mg. This is equation 1. Now we can write equation for board. So we can write in vertical direction as well as in horizontal direction. So let us first write in vertical direction. So we have upward direction n, and in the downward direction we have n dash and mz. So we are taking upward direction is positive. So n is positive, n dash is negative, and mz is negative. And this sum comes out to be 0. So we can say n minus n dash is equals to n2. So this is equation 2. Third equation we can write in horizontal direction, that is t is equals to mu n. Now let us add equation 1 and 2. So we can add equation 1 and 2. So we will have t plus n dash is equals to mz, n minus n dash is equals to mz. So this becomes t plus n is equals to m plus m into z. So we have this equation, and we can plug the value of tension in this equation, or we can plug the value of normal reaction because we need tension. So we require tension. So let us plug the value of normal reaction, that is T by mu. So this becomes T by mu is equals to m plus m into z. So from here we can write 1 plus mu by mu is equals to m plus m into z. So tension is equals to mu times m plus m into z divided by 1 plus mu. The same tension we have calculated in the first part. You see, we can solve the same problem by considering different as systems. One important point you see, in this case if I add equation 1 and 2, the equation I am getting is same as, so this equation t plus n is equals to m plus m into z. This equation is same as this equation t plus n m plus m into z. So basically if I am taking a smaller system, man is separately and board is separately, we are having one more equation. You see, we have extra equations. So in this case we are getting 3 equations. But we have also increased the number of variable n dash. This variable has increased. So important point, how to take the system is very important. If you take a bigger system, then you will have less number of variable. If you will take a smaller system, you will have more number of variable. So what you are looking for, that is important. If you are looking for a force that is applied on the whole system, then you consider a bigger system. And if you are interested in forces inside the system, you have to consider a smaller system, that is parts of the system you have to consider, and then you have to write free body diagram and you can solve equations.